Hey guys, how you doing? It's Coach Scott. Let's start talking about Unit 6 again. Let's finish up with Unit 6. We're going to talk about some properties of matter, right? So just get everything we've got understanding and we all understand how things are. Let's look at gold, right? Gold's a substance, right? But let's think about some of its properties. It's beautiful, right? It's lustrous. Uh, it's got a very soft metal, very non-reactive, and it's a solid at room temperature. Now, salt water is transparent, it's liquid at room temperature, it can be separated by heat, right? You can separate the salt from the water, and there's no definite composition. Pure water is transparent, it's liquid at room temperature, it's got a definite composition, and you can separate it with an electrolysis unit. Calcium carbonate is solid at room temperature, it's got a very high melting point, non lustrous, and it can be separated by heat. It's possible. Now, physical properties. A physical property is a characteristic that can you can observe without altering the identity of the material. Okay, so physical properties of water. It melts at 0 degrees C at standard pressure. Water is transparent, water white, we call it. Water has a density of around 1 gram per milliliter at 25 degrees C. Water is not soluble in gasoline. Water is colorless. Now we can observe this without changing what water is. It's still going to be water. Now, uh, there's that pizza place on Germantown. Y'all know what I'm talking about. They make you pick your own pizza toppings out, and they'll throw it in a brick oven pizza. That's great. Now, what brick ovens? They line the oven, right? The bricks, and these are made of a mixture of aluminum oxide and silicon oxide. Um, think about a brick. What are the physical properties that make it up? All right, and you can use high or low. Just think about it. We'll come back about it. Take a minute. Of course, we're going to do this in class. It's got a very high density, a very high melt point. They're sort of reddish, and they're very brittle. Okay, it's going to break. It's not going to bend. Okay, so um, there's some chemical. Let's talk about the difference between a chemical and a physical change. Chemical changes uh, will move those atoms around and you'll create a new substance. Think about some of the ways we do this with combustion, oxidation, decomposition, there's others. Physical changes are changes that doesn't change the composition of a substance. When we melt ice, it's still ice. So these are things like changes of state, temperature, volume. All right. Some chemical properties we use to describe a chemical change, right? These are things we see when these changes do occur. And some things we've used, you might have talked about these in elementary, middle school. A color change. When you go from white to blue, or from blue to white, something's happened. When light is emitted, when you form a precipitate, which is a solid from a liquid, when a gas is produced. These are chemical changes. So think about it. I've got a little fire pit out in the backyard. So if I light a fire and I create, um, I'm combusting it, right? I'm burning the wood, right? So it's emitting light. Then I get some marshmallows and I put them on a stick and I put them over the fire, right? They're going to turn brown. Chemical change. When I mix two clear liquids together, we'll probably do this in class, and I form a solid, then this is a precipitate. When I add a uh, when I add a powder to a clear liquid and I produce a gas, little bubbles, all right, then I'm making gas, right? I'm producing gas. So let's look at the pepperoni pizza and the brick oven. Let's just look. Now the pizza is going to react with oxygen and it's going to burn. The brick does not burn in the air, all right? But that pizza becomes delicious. All right, when I cook and I make a delicious, I love open face grilled cheese. All right, when I put it into the to the air fryer, I think I use an air fryer, right? I can melt the cheese or I can burn it. If I melt it, it's a physical change. When I burn it, right, when I'm like, or I make it change color, right, then that's burn it. When I cook it, that's a chemical change. I'm changing the substances that make up the cheese. Extensive property, and we're going to talk about these for the rest of the year. These are the properties of in which their value depends on how much of the stuff or matter is present. So I can have different volumes of water. One can hold 30 grams, one can hold 50 grams. That's an extensive property. I can have a piece of wood that's 12 meters or 2 meters. Still wood, but there's different sizes. I can put 14.7 liters of helium into a balloon, or I can put 10 liters of helium. Okay? Those can change. Intensive properties is totally independent of the amount of the material. It just doesn't matter. So water is water white, it's transparent and colorless. Iron is going to melt at 1538 Celsius. Doesn't matter if you got a little bit or a big piece. It's going to start to melt at 1538. I'm going to need the specific heat of aluminum, which is the amount of energy required to raise 1 gram of aluminum by 1 degree C. For 1 gram, I'm going to need 0.89 joules per gram per degree C. All right. That's not going to change. The amount of heat could change depending on how many grams I have. All right. But the amount of heat for 1 gram for 1 degree C does not change. Those are intensive. Now density, this is an excellent example of a intensive property. It doesn't matter how much stuff you have. That ratio, that word again, that ratio of mass to volume is going to be the same for that substance. If you have a higher volume, you're going to have a higher mass. You can look on this chart right here and see it. The density doesn't change. Only the amount of, if the volume increases, the mass of the water increases. All right. So if you look at a meteorite that you find on the Earth's surface, and it's got a solid metal. So what are we going to do to determine what it is? We're going to look at intensive or extensive. Well, I'm going to look intensive. I'm going to try to find its density. All right. If I find that its density, all right, it's not the same as iron, 7.78. So it's something else. So then I'm going to look around and find out what else it could be. So here's a summary. All right. This concludes Unit 6. So a physical property, you can observe it without changing what the property is. Think about melting point, density, color, solubility, hardness. These are physical properties. If it's intensive, it doesn't matter how much what the sample size is. This is like color, melting point, density, freezing point. It doesn't matter how much it is. It is what it is. Extensive does depend on the sample size. This is like mass, length, volume, things like that. All right. A chemical change, you observe it by changing the identity of a substance. Something like the reactivity with other substances and what happens. Okay, guys, that's Unit 6. This is Coach Scott saying Hallabaloo, connect, and have a wonderful day. Toodles.